To defend against automated cyber threats, organizations require machine speed response times. This operational reality drives security teams to adopt Agentic AI, systems capable of chaining tasks together and executing actions without human prompting. Consider a specific high-stakes scenario. An Agentic AI detects malware on a server. It maps the threat actor's behaviors, confirms the infection, and automatically isolates the host from the network. The isolated asset is a life support server. The procedure to quarantine the machine was technically flawless, but in the context of a hospital ward, the action is disastrous. The system fails because an AI executes programmatic best practices exactly as written. It lacks the business context required to weigh the operational risk of a severed connection against the security risk of a contained virus. Human-in-the-loop design serves as a permanent architectural requirement to prevent contextually disastrous automation. At GovWare 2025, top security architects gathered to define the new boundaries of autonomous defense. Security teams often treat human oversight as a checklist for governance and compliance, ignoring its technical necessity. The technical reality is that LLMs possess structural flaws, such as context blindness and inherent sycophancy, that make true autonomy impossible. LLMs, or large language models, are algorithms that predict the next word in a sequence based on vast training data. We have to map these mathematical limits, establish hard operational boundaries, and engineer the specific validation mechanics required to keep these systems safe. Securing AI requires abandoning the illusion of full autonomy. Human judgment must be engineered directly into the system's architecture. AI systems simulate language using probability matrices, but they lack the intrinsic motivation to self-correct or improve. Because they are optimized via reinforcement learning to be helpful, LLMs possess a dangerous compliance reflex known as sycophancy. This sycophancy means an AI cannot reliably distinguish between a legitimate administrator's instructions and an adversary's prompt injection. Prompt injection is a technique where malicious instructions are hidden within normal inputs to hijack the AI's intended behavior. This diagram shows the AI pipeline. The central processing layer operates as a structurally unauditable black box. Because we cannot audit this internal reasoning, we cannot enforce deterministic security rules inside the probabilistic model. This forces security architects to physically concentrate oversight and control at the absolute edges, the input data and the output actions. The AI cannot intrinsically protect itself or explain its internal logic. External boundary architecture is the only viable defense mechanism. Building these boundaries requires specific infrastructure components to enforce human policy on agentic systems. The first layer of defense uses guardian agents. These are separate AI systems explicitly built and tasked to monitor the behavior and intent drift of the operational agents. This diagram illustrates the MCP proxy. It acts as an enforcement gate, intercepting the AI's output before reaching the enterprise API layer. Certain actions are categorically locked behind human approval. The system halts financial transactions or outbound communications until human review. Beyond the proxy, engineers establish a hard perimeter for external override controls, kept entirely outside the AI environment. No matter how sophisticated the AI becomes, an absolute kill switch must be installed. This system termination control operates independently of the AI platform.
True control in an agentic security operations center relies on these hard-coded physical infrastructure intercepts rather than trusting algorithmic constraints. Leaving these agents to run unsupervised carries a long-term systemic risk, structural degradation. This graph illustrates model collapse, which occurs when a closed-loop AI trains on its own synthetic data. As the AI loops generated data back into itself, the output reliability spirals downward, becoming entirely unreliable. The solution is a Tier 3 human feedback loop. Injecting verified human data into the system stabilizes the curve, instantly pulling reliability back upward. This continuous injection of human-curated data provides the necessary entropy to reset the AI's baseline and prevent mathematical collapse. This creates a hidden operational risk, de-skilling. If human analysts stop performing manual validation, they lose the expertise required to provide this critical feedback. Human oversight provides the necessary entropy to sustain the AI's mathematical accuracy, acting as a thermodynamic requirement for the system.
These operational boundaries extend beyond the local enterprise network and out into the global cybercrime ecosystem. An AI can map thousands of data points and identify the specific tactics, techniques, and procedures used by ransomware groups, but the AI cannot perform legal attribution. Packaging that threat intelligence and executing real-world legal takedowns requires human institutional action. Sending a definitive message that threat actors are not invincible relies entirely on human prosecution and arrests, not automated network blocking. While AI accelerates the speed of defense, the final delivery of accountability and consequences in cyberspace remains strictly a human capability. Inside the enterprise, the ultimate decision-making authority rests with the Chief Information Security Officer, risk officers, and the board of directors. They have to bridge the final gap that AI cannot close, prioritizing which of the 200 identified threats the business can actually afford to mitigate today based on resource constraints and risk appetite. Human judgment translates raw, technical threat data into actionable financial risk language. This dashboard illustrates the persona-based model. Oversight is tailored to specific roles: tactical alerts for the SOC, KRI metrics for the risk officer, and strategic financial impacts for the board. KRIs, or key risk indicators, are metrics to provide an early signal of increasing risk exposures. This transforms the CISO's mandate, transitioning the role from an operational security blocker to an enabler who governs the safe adoption of AI across the business. Boards hold fiduciary responsibility for the organization. Final accountability for systemic risk rests with human leaders. The AI can advise, but it can never authorize strategy. We project the operational reality of the enterprise security team 5 years into the post-AI future. The industry is moving away from a massive pyramid of human analysts performing manual security tasks, shifting instead to an apprenticeship model. A smaller, highly skilled team of human operators will supervise a massive automated pyramid of AI agents beneath them. The human defender acts as the strategic captain of the starship, setting the destination and the boundaries, rather than working as the engine itself. Human architects govern and supervise machine-to-machine conflict, providing the strategic direction for the automated front line.